Jai Hind everyone. My name is Nandita Goyal and today I'll be covering the topic propositional logic from the subject theory, discrete structures and theory of logic. The contents that I'll be covering in this lecture include the introduction part, then what is a proposition, what do we mean by a compound statement, then what are formal propositions, what are conditional statements, and what are the propositional equivalences which are there. Now, first of all, discussing that what do we mean by logic. So, logic is basically used to distinguish between any valid and invalid mathematical argument. These were basically the concept of logic was developed by Aristotle and its applications are mainly in computer science when we talk about designing the computer circuits or construction of computer programs. Even we use these logics for the verification of correctness of programs. So, it basically plays an important role in computer science. Logic is a system which is actually based upon proposition. So, in order to understand what logic is and how it works, we need to have a good knowledge about propositions. So, what is a proposition? By definition, if I talk about a proposition, it is nothing but a declarative sentence which can hold only a single value at a time, which might either be true or false, but it cannot be same at a time. So, any statement which can hold only a single value, that is true or false, we can call such a statement as a proposition. To talk about a few examples, let's take the first example. Tunku Abdul Rahman was the first Prime Minister of Malaysia. So, this sentence will either have a true value if he was or a false value if he was not. So, it is having a true value. So, I can say that this is a proposition because it is holding only a single value, that is true. Then 1 plus 1 is equal to 2. So, it is true. It is not false. So, we can say that it is having a single value, that is true, and so it is a proposition. Now, the third one, what time is it? Now, such type of questions or commands cannot be considered as propositions because they don't have any value which can be assigned to them as true or false. Now, if anybody asks what time is it? Now, it cannot have a single value. I can tell the time might be as 11:12. The other person is having a watch which is showing the time as 11:13. So, it cannot have a single value which can be true or false. So, we can say that such type of statements are not propositions. The fourth statement, that is read this carefully. This is again not a proposition because it is a command. So, the commands don't come under the category of propositions as they cannot hold a single value true or false. Then the fifth example, that is x plus 1 is equal to 2. Now, it can have multiple values depending upon the value of x. If the value of x is 1, then this statement will have a true value. But if it has a value 2, then 2 plus 1 is equal to 2 will have false value. So, it can have more than one value and the value will actually depend upon the value of x. So, such a statement cannot be a proposition. So, we can see that the propositions are the declarative statements which will always hold only a single value, that is true or false. Now, these propositions are actually denoted by small alphabets like P, Q, R and small s. So, these are the notations which we will be using to show the propositions. Now, we have something known as compound statements. So, when many mathematical statements are constructed by combining one or more propositions, we call them as compound propositions. When we have a single proposition, we call it as a atomic proposition. But when we combine one or more propositions, then the propositions become compound statements or compound propositions. One or more propositions can be combined to form a single compound proposition using connectives. So, these connectives are nothing but the logical operators. An example of a compound statement is given over here. John is smart. He studies every night. Now, these are two different statements, that is John is smart, he studies every night. We have combined this statement using this or. So now it becomes a compound statement, that is John is smart or he studies every night. So this is what do we mean by a compound statement. And same way, if I join two or more prepositions using some connectives, I can call it as a compound proposition. Here the connectives are logical operators through which we will be combining different prepositions. Now we have different logical connectives. The first one is AND. This AND is denoted by the symbol shown in the table, and the name of this operator is known as conjunction. Whenever we have a AND operator or we combine two statements using AND, the name is conjunction and the symbol is shown here. Okay, the another connective which we have is OR. So the OR is shown by the symbol and it is known as disjunction. We also have a NOT connective. So NOT connective can be shown by these two symbols, and the name of this symbol is negation. So these are the three logical connectives which can be used to form compound propositions. Now we have something known as truth table, which are basically there to check the truth values of the propositions. So these truth tables can be used to show how the logical operators can be combined, can be used to combine the propositions or can give the values to compound propositions. It displays the truth value that corresponds to all the possible values of the truth table for its compound statement variables. The truth value for the proposition can either be true or it can be false. Now, talking about the formal proposition, we have the formal propositions in which we make use of these logical connectors which we have already discussed, that is NOT, conjunction and disjunction. So first of all, talking about negation or NOT, if P is a proposition, then negation of P is denoted by the symbol tilde line followed by the name of the proposition, and it is read as not P. For example, if I have a statement, today is Friday. Now to find out the negation of this statement, today is Friday, what we will do? Today it is not Friday. So we will just negate the statement. So whatever it is saying, we will just add a not to it. So today it's Friday, today it's not Friday. Now the truth table for the negation of a proposition is whenever you have a proposition whose value is true, we will just negate it by making its value as false, and if the value of the proposition is false, then it will become true. So looking at the truth table, we can have two inputs, that is either true or false. For true, the negation will give me false, and for false, the negation will give me true. Now moving to the conjunction. Conjunction of proposition basically means adding a AND. That is, let P and Q be two propositions. The proposition P and Q is denoted by this symbol P and Q, and it is true only when both P and Q are true. If the individual values of both the proposition P and Q are true, then only the conjunction will give me a true value, otherwise it will give me a false value. For example, students who have taken calculus and computer sciences can take this class. Now for this should be true, this should be true. Only then I will get the truth value as true. If any one of them is false, then my truth value for the combination will always be false. So the truth table for conjunction for any two propositions is given as follows. I have two propositions P and Q. The first combination of input values, both are true. In second, first is true, second is false. In the third one, first is false, second is true, and in the last one, both are false. So wherever both are true, only there I will get the value of conjunction as true, otherwise all the three values are false. So the conjunction, for conjunction, whenever we will apply these to any two propositions, the final output will be true if the individual values of both the propositions is true. Now talking about the disjunction operation. Disjunction is if I have two propositions P and Q and I use a OR operator, that is P or Q. So these will only be false. The output value for P or Q will only be false if both are false. Even if any one is true, it is going to be true. If both are true, then also it is going to be true. Now, students who have taken calculus or computer science can take this class. That means if any one of these statements is true, then I'll get the output as true. Otherwise, I'll get the output. If both are false, only in that case I'll get it as false. So, let's look at the truth table for disjunction. I have two propositions P and Q. The first input is both are true. The second input is first is true, second is false. Third one, first is false, second is true, and in only the last one both are false. So, according to the definition, I'll get only a false if both are false. So, only the last one is false, otherwise all are true. So, this is how a disjunction will work. Now, let's take a few examples and we have to tell whether these are true or false. So, now looking at the first example, ice floats in water and we have the operator as and 2 plus 2 is equal to 4. That means the left hand side is one proposition, right hand side is another proposition, and these are connected by an AND operator. So, the output will be true only if both the propositions are true, otherwise it is going to be false. So, ice floats in water, true, then 2 plus 2 is 4. This is also true. So, since both are true, the value or the output for the entire proposition is going to be true. Now, the next one, China is in Europe. This is one proposition. We have again connected it using this and 2 plus 2 is equal to 4. This is another proposition. So, again, the final output is only going to be true if both the propositions are true. But China is in Europe, false, and 2 plus 2 is 4. This is true. So, this is actually false. Even if my one proposition is false, the final output will be false. Now, here I have two propositions again. 5 minus 3 is equal to 1. These are connected by using this operator OR. 2 into 2 is equal to 4. So, when I have an OR operator, I'll get a true value if both are not false. If both are false, only in that case I'll get a false value. So, 5 minus 3 is equal to 1. This is false. Then 2 into 2 is 4. This is true. So, I'll get a true value. So, these are how we determine the truth values of the statements. Then, moving to the next example. Now, I have these four propositions P, Q, R, S. So, P says Anwar is a good lecturer. Q says Hidayah is a good lecturer. Then R says Anwar's students hate mathematics, and S says Hidayah's student hate mathematics. So, now we have to express these propositions using the symbols P, Q, R, S, and we have to use the logical connectives. Now, the first one which we have to represent using symbols and connectives, Anwar is a good lecturer. So, Anwar is a good lecturer is denoted by which proposition? Small p. His students not hate mathematics. Now, we are talking about Anwar. So, Anwar's students hate mathematics. This is R. To make it not hate, I have to negate R. Then, we are saying that Anwar is a good lecturer, okay, P, and that means we have to join these using which connector? Conjunction. So, this is the output. Now, this basically means P, Anwar is a good lecturer, not R. Whatever was the value of R, we have negated it and then we have joined it using a conjunction because there was a and in between. Now, moving to the next one. Either Hriday is a good lecturer or she is not. So, good lecturer means Hriday, that is S. Not a good lecturer means not S. And we have to join it using OR. So, S or not S. Now, Anwar's students both hate and do not hate maths. So, the Anwar students hate maths is R and first, so R, not R, and we will join it with AND operator. Now, the next one is Either Anwar is a good lecturer or his students hate mathematics. So first we'll talk about the first part. Anwar is a good lecturer. So that is given by P. Okay, Anwar is a good lecturer. This is given by P. Then his students hate mathematics. Anwar's students hate mathematics. This is already there. So we have R. Now they are saying or. So or means P or R. Then again we have another sentence. So here we have P or R. Then Hidayah is not a good lecturer. So Hidayah is a good lecturer. It's given to me in Q. So I have to first negate Q. And then I have to join it using a AND. So this is my final output. P or R and not Q. Now Anwar is a good lecturer. That means we are talking about P. His students hate mathematics. R. Now in between they have given but. But means and. That Anwar is a good lecturer and his students hate mathematics. So we'll join it with the conjunction only. Neither Anwar nor Hidayah is a good lecturer. So we have to negate both the statements, that is not P and not Q, and then we have to join it using or. So this is how we represent these compound propositions using the symbols. Now coming to one more example, here they are saying that let P and Q be the propositions. P says it is below freezing and Q says it is snowing. Now we have to translate these sentences using P and Q and logical connectives. So it is below freezing. So this is given by proposition P. It is snowing, it is given by Q, and since we have a and in between, we will use conjunction. It is below freezing, P. Not snowing means we will just negate Q, and then since there is but means and, so we will use a conjunction. Now it is not below freezing, that means not P, and it is not snowing. Not snowing means not Q. And since we have a and in between, we will use a conjunction. Now the third one, it is either snowing. Snowing means Q. Below freezing means P or. And then we even have or both. Or P and Q. Both means P and Q, and since we have a or in between, we have added this or, and this was the first part. So this is how we can convert these statements using the symbols. Now this example shows how to create the truth table. So we want a truth table for a proposition P and not Q. So P and not Q means that we have two variables, that is P and Q. So for these two variables, I can have a total of 4 different input values, that is both the propositions are true, first is true, second is false, first is false, second is true, or both are false. Now I'll negate Q because I want to find out P and not Q. So not Q means whatever is the truth value of Q, just reverse it. So for first one it will become false, for the second one false will become true, true will become false, and false will become true. So I have got not Q. Now what I have to find out, I have to take the conjunction of P and not Q. Conjunction basically means wherever we'll have both true, only there I'll get the true, otherwise I'll get a false. So only in this line, in this row, I'll get a true. Otherwise, since one of my input is false, I'll get a false. So this is my truth table for P and not Q. Now we have to complete this truth table. We are already given two propositions P, Q, and what we have to do, we have to find out the truth value of P or Q and not P or P and Q. So what we'll do, first we have inputs for P and Q, both are true. First is true, second is false. First is false, second is true, both are false. So P or Q means we are taking the disjunction. So wherever both will be false only, there I'll get a false, otherwise I'll get a true. So I'll get a false only over here. Otherwise all will be true. Okay, now if I take the not of this, first I'll actually need to find out P and Q. P and Q will be, I'll get a true only when both are true, otherwise I'll have a false. So I'll get a true only here and rest all will be false. Okay, now negating this P and Q, what I'll get? In place of true I'll get a false, and in place of false I'll get a true. Okay, and now taking the conjunction of these two columns. So wherever I'll have both true, I'll get a true, otherwise I'll get a false. So I'll get a true over here, I'll get a true over here, otherwise I'll get a false. So this is my final output. So this is how we draw the truth tables for formal propositions. Now we have some conditional statements, two conditional statements. The first one is known as implications. If I have two propositions P and Q, okay, and I have an implication P implies Q, this symbol is basically used to show the implication. Then this is a proposition which is false only when P is true and Q is false. Otherwise it is true. It basically means if P then Q. This basically means if P then Q. This is the meaning of implication. So whenever P is true, Q should be true. Okay. Q cannot be false if P is true. Otherwise it is always true. So we express it as if P then Q, Q when P, or P implies Q. We can express it in any way. Here P is known as hypothesis or premise and Q is known as conclusion or consequence. Let's take an example. If you earn A in logic, then I will give you present. It means that if A is true, then if I say that this one is my P and this one is my Q, it means that if P is true, then Q has to be true. It cannot be false. So let's check it with the truth table. We have P and Q as propositions. First, both the values of input are true. Then first true, second false, first false, second true, and then both are false. So as we have discussed implication, if P then Q should be true, and it is true. Okay, if P is true, Q is false, this cannot happen. So this is going to be false. Otherwise it is always true. So if this is false, this is true, it is true. If this is false, it can be true. So the only thing when it will be false is if P is true, Q cannot be false. So this is going to be false. So this is how an implication will work. Now talking about the equivalence or biconditional statement. The biconditional statement says that let P and Q be two propositions. The biconditional statement, this is represented by this bidirectional arrow. This is the proposition that is true when P and Q have the same truth values. Otherwise it is false. If both have the same truth values, then it is going to be true. We express it as P if and only if Q. Let's take an example. You can take a flight if and only if you buy a ticket, or you can have a dessert if and only if you finish your meal. So these both, if I take it as P and I take it as Q, so if this is true and this is true, then I'll have a true, and if this is false and this one is even false, then I'll have a true, otherwise I'll have a false. So let's check in the truth table. If both the inputs are true, then it is true. If both the inputs are false, then also it is true, otherwise it is going to be false. If any one is false, then it is false. So this is how a biconditional statement will work. Now we have the converse, inverse and contrapositive for implications, that is P implies Q. So let's see what is converse, inverse and contrapositive. So my implication says that if P then Q. The example is if it is raining then the home team wins. This is my P over here and this is my Q. Now the contrapositive says, now the converse says that P implies Q's, converse for P implies Q will be Q implies P. So we'll just reverse the direction. So it means that if the home team wins, then it is raining. The inverse for the same statement, P implies Q, is not P implies not Q. So that means we'll just negate both the statements. So if it is not raining, then the home team doesn't win. And if I talk about the contrapositive for P implies Q is nothing but not Q implies not P. That is, we'll negate both and we'll change the order. So if the home team doesn't win, then it is not raining. So this means that we can show the converse, inverse and contrapositive for each implication by using these rules. So that's all for today. Thank you.